Hi and welcome in this new video. This time I will show you what happens when you call Coalesce method in Apache Spark. In your screen you can see that I'm using RDD abstraction, but it's normal because under the hood, and I will show you it a bit later, Apache Spark uses RDD to execute the Coalesce operation on top of dataset or data frames on top of Spark SQL in general. So to show you that, I will go to the data frame dataset class rather and look for Coalesce. And as you can see, we are adding some repartition node with the shuffle attribute set to false. When you check how this repartition node is translated to the physical execution, you should see that it will create a Coalesce exec method that under the hood will call RDD Coalesce as long as you don't have an empty dataset, of course. So this RDD Coalesce method is exactly the same method that I will call from my sample code, as you can see just here. And I added some breakpoints in the code, and let me show you them. So I added mainly the breakpoints in the Coalesce curve class, which is responsible for dividing the input dataset into smaller partitions. So you can see that there are three main methods. So the first method is the method where Apache Spark, if there is some data locality concept, will group all partitions sharing the same executor, sharing the same physical location. Later we will create the first groups of Coalesce partitions and at the end associate remaining input partitions to these groups. And in my demo code I will call Coalesce for 5 partitions, and I will use a very dummy example RDD which returns every time a few two rows and puts them to corresponding executor called in this demo host1, host2, and host3 according to the partition, to the input partition number. And as you check, it's very straightforward. It's just to simulate the data locality concept, because if you check the implementation, for the case where data locality is not there, Spark will simply divide rather equally the input partitions to the Coalesce and put them to a Coalesce partitions. So that's the reason why I would like to focus here on this bit more complicated example. So let me run the code and see together what happens. So the first thing to do is that, as you saw, Apache Spark allocated the input partitions from our RDD to the executors, to their physical location. And you can see that under this variable, where you can see that we have two buffers, one to store input partitions without location, which doesn't happen in our case, but which could eventually happen if you do some union between locality sensitive and not sensitive RDDs. But anyway, here you can see that we have exactly 4 partitions for every input, for every executor, for every host. Later Spark will create the number, the Coalesce partitions we want. In this case it's 5. So first it will try to allocate, to create a partition group for every executor. So in our case it will stop after 3, because we have only 3 executors, 3 distinct locations. So as you can see here, we have a group which corresponds to host 1 and which stores already 1 partition. We also have now the second P group which stores the partition number 4, and finally we have the host number 3 with the partition number 8. And here, as you can see, if there are some still missing Coalesce partitions, remember we want to create 5 and we have only 3, Spark will iterate through remaining input partitions and create the missing partition groups. So here it should iterate only twice. As you can see here, we create a peg group for host 2, so we have already the groups for host 2, and the second will be for the host 1 and for the input partition number 2. So after that, after this method, we have Coalesce partitions, and now Spark will iterate over all remaining input partitions, and by remaining to check whether the input partition was already processed or not, it will check this guard and verify whether the initial hash contains the input partition or not. And if it's not the case, it will pick bin, so it will choose the partition group to allocate to this Coalesce, to this input partition, and it will do it in two different manners. At the beginning, it will retrieve two Coalesce partitions randomly, and it will take the one which has less data with less input partitions stored. And later, if we don't have any data locality, it will take these smaller Coalesce partitions, so that the number of input partitions in the Coalesce partitions will be roughly equal, even over all Coalesce partitions. But if there is some data locality aspect, it will verify whether the number of partitions in the randomly chosen Coalesce partition plus a slack, which is 10% by default. I will show you that. As you can see, it's 10%. And if this number is lower than the number of partitions, on the number of data locality Coalesce partition, it will choose the randomly chosen partition to prefer, as you can see, to prefer the balance over locality, and otherwise it will go to the locality aspect. So as you can see, we skipped already the partition number 0 because it was already put to the partition group. Now we will go and choose the Coalesce partition to the input partition number 1, which is the one for the preferred data locality. For the partition 2, we will skip, and we will choose now the input partition for the Coalesce partition for the partition number 3. And we will probably put it to the host 1, if I'm not mistaken. Yes, you can see that it will put it to the host 1 when we already have the input partition number 2. So now we are in the 4th, and we will skip it or not. Yes, we will skip the input partition number 4, but we will not skip, we will also skip the partition number 5, in fact, and number 6 should be allocated, yes, and we will prefer the data locality here. What will happen for the 7th? Also data locality, input 8 will be skipped, 9 will prefer data locality, number 10 also, and let's see what happens for the number 11. You can see that this time we prefer to balance these partitions evenly in the Coalesce partitions, and that's the reason why we don't prefer the locality aspect here, simply because if you compare the partitions, you can see that if we added this input partition to the Coalesce partition group that you can see on the screen here, it would be at least twice as big as the randomly chosen input partition. And to balance better the distribution, we will go for the randomly chosen partition. And globally, that's all to know for the Coalesce operation involving the data locality aspect. And if you want to discover more details on the implementation code and also to learn a bit more on the no data locality aspect, I invite you to the article which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.